Okay, we're going to do a test on the refrigerator, but what we're going to do first is go over some of the things that I was saying in the last video. I was doing tests earlier today, so I ran the batteries down a little bit, so I'm using the battery charger to charge it up. I got it on 12 amp right now. I've got the amp probe on there. It's saying 15 amps. Got that down there on the battery charger wire. That's the clamp for the battery charger. And we're sitting at about 12.8 volts charging, so we're still not quite fully charged. In any event, that's where the numbers sit right now. And showing the voltage there. What I'm going to do is I'm going to kick that switch on. This will fire up, and we're going to watch this here. But the other thing that's going to happen is that this capacitor is going to kick in, and you'll see how fast that refrigerator fires up. I'll do another video, or I may have done or have a video already that shows it firing up without the capacitor. But anyway, let's watch what happens. I'm going to get so you can see both of them. Alright, here we go. See how fast that fired up? Like less than a second. Okay. Now, refrigerator's up and running at 120 volts. .65 amps, 316 watts. As it equalizes, it'll or builds pressure and whatnot, it'll come down a little bit. Runs about 280 watts. There's my cost per kilowatt. That was my kilowatts used, and we're at 1 hour 9 minutes, and it says we've saved 3 cents at 11.7 cents. Let's see, get back to the dollars. That's per hour, that's per day, that's per week, and that's per month. So that's basically 10% of my bill. It runs about 200 plus a month. So, alright, let's see here. Let's go back to kilowatts a minute. 0.32. Alright. See if we 260 watts, 270 watts. Alright. I just wanted to show that. Now 12.4 volts. Okay, now that the electricity's like pressure. Anyway, now that the voltage is equalized, this unit's shut itself down, and it'll wait for the next spike. And what'll happen if the refrigerator shuts off? Basically, we won't be drawing any juice, so our voltage will go back up, and this will absorb that voltage and recharge itself. And then the next time there's a massive, not spike, but massive dip or draw on the lines, it'll discharge and make up the difference for that huge demand all at once. So that's just something I added into my system that some people or nobody I've seen add into theirs. So this particular unit can be picked up at Walmart for about $80 or so. This one was used. You can probably find them at pawn shops. It's one of those items that I'm sure is in and out of a pawn shop. Stereo equipment. Oh, let's see here, what else? I wanted to see about using these for fuse holder. I can mount this on the wall. I can use it for a fuse and a switch, and it says it's good for 250 watts. Well, I don't know if you can see it. It says 250 watts, 250 volts. That's what it says. So it should be able to handle anything that I want to put through it. I mean, just simply fuse the DC side of my, the solar panels coming in. My main thing that I was thinking about using them for is to what am I trying to say? I can use one to fuse it before it goes into my charge controller, and I can use one to fuse it coming out of the charge controller going to the batteries. So that would basically isolate or protect that. And these fuses anymore can be picked up at secondhand stores and garage sales and auctions, and I got a pile of these things. How I got them, I don't know. But I was going around in my junk in my shed, and this is what I came up with, and I was like, I'm going to try that. Now this particular fuse is a 15 amp, and that's about all these are good for, about 15 amps, maybe 20. So if I use it to fuse my solar array, if I put two of these together, I got 4 units, 4 solar panels at 230 watts, and what I haven't put up there yet is that each one of them is about 8 amps. So if I run these 2 of those panels together at 74 volts, and I can run it in and fuse it. I can put them side by side and fuse 2 of them. Let's see what that looks like. Yeah, something like that. Well, the other thing is I was going to put that Xantrax controller there, but I think I might have told you that it's not going to work for this application. Not with the solar panels I have. So I have to get a Outback, and I'll put it right here somewhere. And that's going to take a little bit because those are a little pricey, about $500 bucks. All right. Anyway, that's all I got for you. Just testing some stuff out. So, refrigerator's still been drawing 260, 255. Oh, I was testing this earlier today, and during the the defrost cycle, it was drawing 450, 460 watts. This refrigerator's an energy hog and never shuts off. That's what I found out today by running everything through it. Drained the batteries pretty quick. Let's see. I want to see what we're at 0, and I'm going to put the amp probe going into the inverter. 21, 20, 19, we'll just call it 20 amps. Did the math on that before. Double check it again. Sorry for the camera shaking. Okay, 20 amps times 12.4 equals 248, and pretty close. If anybody has any knowledge of what a 15 amp, 110 volt or 120 volt AC fuse would relate to in a DC application, let me know. These fuses come in different okay, you get an SL50. Sorry, the camera doesn't adjust, but you can get them in a W, which is for circuits not containing motor-driven tools or appliances. For example, you would not want to use this on a circuit that had a refrigerator on it. It would be more for a lighting circuit because they are more of a fast-acting fuse, and when a motor starts, it draws over amperage. The next one is a TL, which is a TL or a T type for circuits containing motor-driven tools or appliances, and then a type S or SL is for circuits containing motor-driven tools and appliances. Fuse stat is designed to prevent oversized fusing and tempering through their finer and smaller diameter thread, and that would be one of these. So it's kind of, they tried to make it dummy proof, but so I've got a type S here, which would be for using it on something that would have draws, heavy draws for a second. So maybe you could draw 22 amps for a split second without it popping. You know what I mean? And then on this one, this is going to be a type W, or excuse me, yeah, type W, and this is a 20 amp. So if I were to use one of these for two of the panels coming in, I would probably start with a smaller. I'd probably start with the 15, and if I can find anything smaller, I would start out with a smaller one and kind of test it and find out where it pops and where it don't. But I got 15s, 20s, and 30s, and anyway, just trying different stuff, trying to make it cheap, affordable, so you don't have to buy everything, because geez, oh Pete's, bus bars, 4-aught cables, just stainless steel nuts and bolts and washers. You know, every time you go to the store, you're going to get 4 of them, and it's a 25 cents a piece. So basically, every bolt, washer, and a nut with tax, it's going to cost you $1. So this, anything I can incorporate that's free, I'll do it. So now that's it. Video's done. Wish me luck. See you in the next one.